Hey guys, welcome to the tutorial on ImageJ. ImageJ is an open source image processing tool that we use extensively in our lab. So the purpose of this video is to familiarize you with some of the basic operations that you will need to do quite often during the course of your research. What we'll go over in this video is some of the fundamentals of RGB. We'll understand how to quantitatively analyze image intensities. We will look at how to quantitatively measure lengths and areas within images, how to visually enhance images for use in presentations and publications. And finally, we'll conclude with how to analyze videos, how to reduce their size, label them with timestamps, extract AVIs with desired frame rates. These are some of the operations that we do routinely in our lab. So, in parallel to the contents, by the end of this tutorial, what you should be able to do uh, is to understand that an image basically is can be represented by just a set of numbers. At the end of the day, it is just a set of numbers that you can quantitatively analyze. You should be able to, at the end of this video, quantitatively analyze color intensities within any image given to you, quantify distances and areas, and improve image or video qualities or appearance for making beautiful presentations or for use in publications. So let's get started. I will start by opening ImageJ, which always has this microscope icon. This ImageJ, by the way, was developed by the National Institutes of Health within the United States as an open source project. It's one of the most successful open source software for the scientific community. I have a folder open here where I have all the files that we will need for this tutorial. So let's start with the fundamentals of RGB. So if you have a JPG image or any image, you can open it in ImageJ by dragging it into the ImageJ window. So I'm going to start with this picture containing uh, three circles, blue, red, and green, just to illustrate what RGB is. So any image, now this is a PNG image, it's a colored image using the RGB code. What that means is that any pixel within this image is represented by three values: a value for R, a value for G, and a value for B. And all these three numbers are on a scale of 0 to 255. So if you take your mouse pointer to any point in this image J, now keep an eye over here in this bar over here. Whenever I take my mouse pointer anywhere and I move it around, ImageJ shows me the coordinates, x and y coordinates of that point, and three values. In this case, it's saying value equals 255, 255, 255 white. That is because the RGB representation of white is 255R, 255G, and 255B. Similarly, if you were to go to red, pure red color, its RGB representation would be 255R, 0G, and 0B. So let's try that. This is my R, and I can see that my intensity value is 255, not quite 0, but 14, and 0. So it's very close to red, but not exactly red, but you get the idea. Similarly, when I go to green, my middle value should go to the maximum, which is 251, and the other two values are, in this case, 0 and 56. I'm always referring to numbers that are showing up here. And similarly for blue, the blue value will be the highest. If you understand that, you have now understood that any color can be represented by a combination of three fundamental colors, R, G, and B. In this case, they are on a scale of 0 to 255, and that is because this has been taken with the 8-bit camera, but those details I won't go into right now. The next thing to know is, in many cases when we have to analyze, we have to quantify these. So which channel do you pick for quantification? But before you decide that, you need to be able to split this image into multiple channels. So let's do that. I can go into image, color, split channels. What this will do is this will split the colored image into three different images, which will represent R, G, and B. Each of those images will now be a grayscale image. So let's do that. Okay, so I have blue here, I have green, and then I have red. You can use this zoom button, and if you right click, it zooms out. So I'm going to right click, zoom out on all these three. Okay, so now you can see that this was red, by the way, this was green and this was blue. So on a grayscale image, because this is only looking at red intensities, red will be highest near to 255. Again, look at numbers that appear here. Whereas green and blue on a red scale should be close to 0. And that's why you see a value of 0 here and a value of 0 here. Similarly, here the green value shows up as white, which is 251, and others will be very close to 0. And similarly for blue over here. So this is an important thing to do whenever we have a colored image. We often split it into multiple channels and then we decide one of the channels, either red or green or blue, in which we will do the quantitative analysis. So this will become clear as we go ahead through this tutorial. So lessons learned: any colored image has a multiple number of pixels, and a pixel is basically just represented by a set of three numbers, R, G, and B. When you split channels, you have the same number of pixels, which is 523 by 490. Each pixel is now represented by just a single number because this is a grayscale image. Okay, so with that, our next topic is image intensity analysis. And in our lab, there are typically two different kinds of images that we acquire for sensing. There are things that are often on a dark background on which you develop some color. This is typically fluorescence. Or they're typically things on a white background on which you develop not fluorescence but visually visible color. So we'll look at both of those cases and try to do some image analysis on them, or quantification. Let us start with pink over white. This is some work that we do in the lab for the detection of glucose concentrations in the solution. And quickly, I'll tell you that what you're seeing from left to right are increasing concentrations of glucose in a solution. So this is very low glucose concentration, higher and higher still. And clearly by eye, we can say that the pink intensity is increasing, but now we need to quantify it. So as I said, that whenever you want to quantify, you want to first split your color channels. So we'll do that. One thing to note is, as I said, is which color channel do I now pick for the intensity analysis. So because pink color is close to red, okay, I'll probably open this again to go over this idea. So let's look at this image here now. White, as we know, will be represented by 255, 255, 255, or three very high numbers. In this case, you can see the numbers that appear here. They are 207, 206, and 211. Now, if I go from white towards red, then what the coordinates for red in RGB are 255, 0, and 0, which means that from going from white to red, what changed was not my red channel, but my green and blue, because white is maximum R, G, and B, and complete red is maximum R but 0 G and 0 B, and therefore if you have any color that is close to red, you should analyze them in either the green or the blue channels. So if you look at this, you can see that in red channel nothing reflects because pink is very close to red and the R channel barely changed, so we'll discard that. In this case, now you can take a call. So here you can see that within blue it got a little bit dark, but clearly green seems to be the best channel to analyze this. Okay, so this is my green channel, and I can now analyze this. I can again visually see that my intensity is increasing with increasing glucose concentration. So the next thing we do is introduce the concept of an ROI, which is region of interest. A region of interest is nothing but a selection. So it can be a rectangular selection or an oval selection. So we'll start with the rectangle here. And let's say I decide a certain rectangular region on this that I want to analyze. Let's say this. That is because this is where my color is developing. Okay. The first thing to note is that any selection in ImageJ can be represented by four numbers. So you can go into Edit, Selection, Specify. The four numbers that show up here are the width of this box, that is 33 pixels, the height of this box, which is 40 pixels, and the X and Y coordinate of the top left point. Okay, which means that the X and Y coordinate of the top left point here are 154 and 23. So we can verify that. If I take my mouse pointer over here, I'm getting numbers on the top bar that are close to 154 and 23. This is often important because if you make a selection to do some analysis, you can note down those four numbers so that you do the analysis on Monday or you want to do the same analysis again on Wednesday. There's no way you're going to be able to make the exact same region of interest unless you have noted down those four coordinates. So it's important to note down those four coordinates. Now, If I want to get the average intensity in this region, I can say analyze, measure. I'm basically measuring the region of interest. And it's showing me the minimum intensity, maximum intensity, and the mean intensity. The mean is often what we are interested in. So this has a mean intensity of 135. And now if I make a similar box, you could make a box of exactly the same size, but I'm using the specify selection numbers, but I'll roughly try to make something similar. I can again do analyze measure. This measurement comes in the line below the top line, and you can see that because you are going from a brighter to a darker color, my mean intensity decreases. And if you just hover your mouse pointer, you can see that in the absence of glucose, my numbers are somewhere around 195. Here they're around 120 or 130, and here they're 50 or 60. So what this shows is that if I get an average intensity, now my average intensity is reducing as my glucose concentration is increasing. Typically in analytical chemistry, you look for a signal that increases with increasing concentration. And therefore, because you're working with a white background, what we do here is we report the inverse of the number. These numbers go on a scale of 0 to 255, and therefore we will report 255 minus this number. And whenever you do that, this will be the smallest number, this will be larger, and this will be the largest. And so this is an important concept in analyzing. You'll find many research publications that don't do this inversion, and they report decreasing signal intensities with increasing concentrations. In our lab, we will always stick to increasing intensities with increasing concentration, or increasing signal that we report increasing concentration. So we will do that inversion. Within measure, there's something, within analyze, there is something called a set measurement. Inside set measurement, you can now click as many fields as you want, and whatever fields are clicked will appear when you do measurement. So right now only area, minimum and max gray value, and mean gray value are selected, and that's why you're seeing area, min, max, and mean. But there are several other things that you can explore within this. Okay, now that is one thing. So quickly now we will look at analysis of green over dark. Now this came from a fluorescent imaging of something. So here it's now the background is not exactly black, but it's a dark background as opposed to a white background on which we are generating green colors. Now here it's very clear that we will analyze these signals in the green channel because they're green in color. So we'll again go ahead and do split channels. We are going to make we're going to get three grayscale images in three different channels. Blue, you can clearly see nothing, there's nothing happening in blue. Green is the one we said we'll analyze, and you can see that it works really well, where as my as I go to the right, the intensity is increasing. I'll talk about in a second what these numbers are. Red also does quite well. It's a choice you could make, but we have determined that green in this case is more indicative, or is more rather sensitive to the color change. Okay. Now what you see N, basically this is a DNA amplification test where N represents lack of DNA, 1 represents 10 to the 1 copies, 2 represents 10 to the 2 copies, and 3 represents 10 to the 3 copies. And visually we are again seeing an increasing intensity with increasing copy numbers. Again we can do analyze measure, but notice that we have circles now as opposed to rectangles. So that is also something that's possible. You can click on an oval and you can just basically start making an oval around any of your regions. So let's say over here. You can make this oval, you can stretch it to exactly cover your region of interest. And even this oval now, you can still go to edit, selection, specify, and even this oval is represented by 4 numbers. Why? Because you've clicked oval, so it knows that it's an oval. The width and the height are basically the major and the minor axis of the oval. And the x and y coordinates are the x and y coordinates of a fictitious point that is formed when you extend a vertical line from this point and a horizontal line from this point. So that will be the coordinates for this. So you can have an oval or a constrained square or circle, or centered. I believe centered will now give you coordinates of the center, whereas we haven't centered it yet. Nevertheless, any selection you make, you can note down its coordinates. Again, you can do analyze, measure, and you'll get the mean intensity. So let's do some quick measurements now. The mean intensity is 62 here in absence of DNA. Let's take this one for 10 copies. By the way, while you're making this oval selection, if you hold the shift button down, it will constrain this selection to an absolute, to an exact circle. So that's something you can, that's something to remember. There are shortcut keys for measurement. I'm on an Apple, it's Apple M. In the Windows, it's Control M. So I just did that. This is for 10 copies. This is for 100 copies. I won't be exact here. I'll try to quickly do something for the sake of illustration. And that's that. So now I have mean intensities for 62, 102, 138, and 158, and they are quantitatively increasing as my signal is increasing. Okay, so here you don't have to do any inversion because you're getting a signal over a dark background. That's the point I've been trying to illustrate here. So that is those are some of the basics to learn. There is a different way of analyzing these things where we do a plot profile and an area under the curve, but that is probably something I'll cover in a different tutorial. It's only used for more where you want to be more particular about what you're doing. By the way, those numbers that are just emerged in my analyze measure can simply be copied and put into an Excel sheet for further analysis. Okay, moving on. We'll now look at measuring lengths and areas within the image. So far we were quantifying intensities. Now we are interested in quantifying distances. So let us take a video where this is a 1 centimeter wide strip in which fluid is added over here. It's kept horizontal, and as the video rolls, you will see that the fluid is getting wicked. And my purpose is to now measure the distance traversed by the fluid front as a function of time. By the way, the backslash arrow on your keyboard in ImageJ gets the movie rolling. That is how I got it. You can always move this scroll bar, but the backslash arrow, so it has started now, and backslash again halts it or pauses it. I go back. Now in this particular case, the device was so made that there are 1 centimeter gradations. So this is one distance between this and this and this and this is 1 centimeter, and this was done for ease of analysis. In many cases you will not have that gradation. So let us now start with, let's say I want to measure the distance. Let's take a certain time point. Let's say the fluid front is here, and I want to measure, let's make it somewhere in between the gradations, and I want to measure the distance from, let's say, this point here to this point. It's very simple. I can draw a line. This is the line selection from whatever point to whichever point I want, and I can again do analyze measure, and now it's telling me that the length of this segment is 128. However, this is in pixels, but we need distance in real distance units, centimeters or meters. So if you know the conversion, of course you can keep measuring things in pixels and then do the conversion later, but there's a very convenient way of doing this. So you can set scale in ImageJ. So I know that, let's say I don't have any gradations, but I know that my width is 1 centimeter, right? That is how the strip was designed. So I can draw a horizontal line here whose width I know is 1 centimeter. So I have that selection here. Then I go to analyze, set scale. Now notice what this has done is it has already measured the distance in pixels of this line. It knows it's 41 pixels. But I want to tell ImageJ that 41 pixels corresponds to a known distance of 1 centimeter. So I'll say 1 here. Pixel aspect ratio is always 1, and unit of length is centimeters. Okay, and I can say OK here. If you do global, it will apply that to every single image that you open, but we don't want that. So we'll just say OK now. ImageJ already knows that the scale is 41 pixels per centimeter. So I say OK now. Now the scale is set. Now I can use my line tool again, and I want to know the distance from here to here. And now when I measure it, ImageJ will report it in centimeters. So it's telling me that this distance is 3.2 centimeters. So this is how you can set the scale. In many cases, you might not know the scale early on, so you can do the analysis in pixels. It really depends on what you're looking for. But having any dimension in this image that's known to you is a very good way of setting the scale. Once the scale is set, and as long as this image is open, the scale will always remain set. So now what you can also do is you can make a rectangular selection, and if you do measurement, you should be able to get its area. So the area of this is 0.714 centimeters square. Let's try to make a square of 1 centimeter square area, and this should be reported as roughly 1 because the scale has been set away. Okay, straightforward. The other thing is that the distance in here, by the way, if you look at the bar over here, when the scale is not set in numbers and pixels, but now it's already showing the numbers or it's perhaps showing both pixels as well as centimeters. So you can see here, just notice what occurs here. At any point, it shows me the distance in centimeter and the corresponding pixel. So this is a useful concept, you know. Okay, that's all I'll say about measurements now. Which brings us to visual enhancement for presentations and publications. So I will actually cover this topic as a part of processing videos and batch files. So what are batch files? We don't usually deal with batch files. When you're doing microscopy, especially mammalian cell cultures, or rather long-term imaging over days and stuff, you will often take a picture of something every hour. And so that is stored by the computer as file name underscore 01.jpg, and the next is file name underscore 02.jpg. So it's always saved in a sequence of names, and ImageJ has a way by which you can simply tell it the base, which is file name, and it will automatically open all figures that all the files which have 01, 02, 03, and so on. What we do instead is we often acquire videos using Handy AVI. What Handy AVI does is it takes a set of images and it already converts it into an AVI and gives it to you. But when you open the AVI in ImageJ, you can now see all of the individual frames that were captured. What happens though is that if you capture images at the highest quality, and often our videos in paper fluidics are 15 minutes, 10 minutes or so. These videos are huge. They can be 1 GB, 600 MB. And I have seen many times that we try to insert those videos into PowerPoints, the PowerPoint file fails or just rejects to open. And so we'll see how to manage this issue, how to shrink video size, how to make them look better, and so on and so forth. So for that, I have chosen a large video. The size of this video is around 600 MB, if you see here. Around 670 megabytes. It has 182 frames. Now, when I open this, if I want to make any major changes, don't use virtual stack. If you don't use virtual stack, which is what I'm trying to do now, the entire 670 MB is actually opened, and you can do all of the required processing. If you use a virtual stack, sometimes the processing abilities are limited, but it saves on the RAM. Okay, and because it's 670 MB now, so this is a typical video that you will get from Handy AVI. These are two different devices in which, as I'm rolling my my pointer here, cursor here, I see or scroll bar, I see the fluid is coming into these devices at different points. They're moving at different rates. You can see that the lighting is generally very poor. And so this is obviously a video at this stage you wouldn't want to put in the presentation. It's also 670 MB. So several things that can be done with this. First thing is I want to crop this. I want to crop it so that I don't see any of the other background, would only see this device. But it's not exactly horizontal. See this line? It's not very horizontal. So I would like to rotate it slightly. So I'd say image, transform, rotate. Here I can set the angle by which it will rotate this image. I can preview it. So right now it's set to 15 degrees. This is 0. Clearly I don't want to rotate it by 15, but maybe I want to rotate it by 1 degree. When I rotate it by 1 degree and I have preview on, I see that this is how it's rotated. I like it. I say OK. It asks me whether it should process all 182 images. I say yes. It will take some time because this is a large video. It's going ahead and processing everything. Done. Now I can crop it because it's straight. And when I crop images, I like to crop them really tight. I usually don't keep anything outside the device that is visible. So I make that selection. I do image crop. This is like any other image processing tool. You can crop these images. So a lot of the data that you didn't require is already gone, right? Everything over here is within the purview of where flow is happening. But it's still pretty large. It's 482 MB as it shows me right now. So one thing to do, the first thing to do is, especially when you want to export a video, is you can shrink this or scale these images. So if you scale it, I went to image and scale. You always want to scale in the same ratio to x and y. Let's say I make it half in the x as well as y direction. And I say OK. What it should do now is that it should reduce the file size by 4x directly, because I had 2x reduction in both dimensions. It's taking some time to do this. Okay, so I came to something that's around 120 MB now. I will minimize this to get this out of the way. This is something I could work with. I could go even smaller, but at that point you may have it so small that when you reproduce it in the presentation it may not be very clear. The other thing that you see here is, now I like the size, there's nothing around it, but it's a very dark video. I want it to be slightly brighter. So this is one of the most important features you'll be using, which is image, adjust, brightness and contrast. This is something you will find yourself doing over and over and over again. And the information here is also very, very important. What this shows me is a scale from 0 to 255 intensity units. And it shows me, this is a histogram plot basically saying the number of pixels in this image that are in this range. So what it is showing you that from roughly around 125 onwards, there's not a single pixel that is intensity in that range. And you can even see that most of the intensities here, if you look up the bar here, 150, maybe the brightest point is over here, 189, maybe a few pixels. So there's a lot of, but what ImageJ does is it says that 0 is black and 255 is the brightest it can be. You can enhance you can make this brighter by moving this slider here. So basically this line will shift here. What I'm telling ImageJ to do is that I want you to think of this number, let's say this is 125 or 150. I want you to think as the brightest possible point and 0 as the darkest possible point. So I'm going to move this slider now, and you can see here that the image gets brighter and brighter. Okay, and usually you would like to have this line covering your entire histogram. What brightness and contrast, usually I never play with this. What brightness does basically is it will move this line up. Basically it will increase the intensity of all pixels. Okay, we don't want that. And contrast will move this one here, this bar here and this bar here. So that it's just changing the slope of that. So typically I don't play with the brightness and contrast. I manually set my slope by changing this. So by the way, if you go here, now what I'm saying is that anything that is intensity below this is black. So there will be several pixels which have intensities below that now begin to appear black. Now I don't really want that. This is just for the sake of demonstration. This I like. I think this is okay. Then I say apply. Again, it will ask me all 182 slides. I say okay. Okay. So now let's roll this movie using my backslash. It already appears a little better. Okay, I'm going to pause that. Now the next thing is, when I want to show this in a PowerPoint presentation, I want to have a timestamp, because if you don't put a timestamp, they're going to ask you, hey, how long is this video? Is this an hour? Is this a minute? Here you see that this is 182 frames. Now, when you capture this in Handy AVI, you know that a frame has been captured every so many seconds. So let's say in this case, a frame has been captured every second. So what I can do is I can go to Image, Stacks, Label. In label, it asks me for what format I want my time label in. Because I know this is going to last of the order of 182 seconds, which is minutes, I can choose this. So this is MMSS, or minutes and seconds. This would be hours, minutes and seconds. So let's choose this format. I want to start at 0 seconds. The interval is basically the number of seconds in between each frame. So I know in this case it's 1 second in between frames. And this is just the X and Y location of the and the font size of the label. So I can do a preview, and it's showing me this thing over here. This is 0 seconds. I usually like my font size to be much larger than that. When you're doing a presentation, it's usually much better. So I can see this timestamp over here, and I say OK. Now if I roll this, this will show me the minutes and seconds of my video. So this is going over seconds. Now remember, in this case, my second number and frame number more or less matches, so this is a difference of 1. But if you had set it to a frame every 2 seconds, it will correspondingly have changed. The other thing that happens is that whenever you take these videos, often this distribution changes over time. And so that's why it's very tricky, because see here, it looks pretty bright. Here it's pretty dark. See the distribution here, I have set it to here. The entire data is between 0 and this point. And when I go deep into this video, there's a progressive shift of this histogram to the left, and it becomes darker and darker. There's often nothing you can do about it. You really need uniform lighting throughout. But just something to be aware of. You shouldn't set something to be so for example, if you have adjusted it to be very, very dim here, by the end you may see nothing. So you have to always be cognizant of that. Okay, I have this now. Now I want to export this as an AVI, so I can put this in a PowerPoint file. So here, notice I have 182 frames. Now, if I export it as an AVI of 1 frame per second, it will make a video that's 182 seconds. That's really boring, right? You don't want that. Typically, when you make a presentation, you want videos that last 5 seconds to 10 seconds. So I say File, Save As, AVI. In this AVI, I can set the frame rate. So if I set the frame rate to 18 frames per second, then I'll make a video that's roughly 10 seconds. Okay. Here there's a compression. Always set the compression to JPG. Say OK. It's asking me where I want to store it. It's in the same folder. I say OK. And now it's extracting here. So the new file that's formed now, this one is only 5.3 MB, and the original file was 670 MB. Okay, so let's close all of this, and let's just play this video, and looks pretty good. It's about as good as you could have done with this video given the really dim lighting in this. Okay, so this covers many concepts, especially the but I do want to enforce the brightness concept on you once more. And so I have what I have is, so what we did here was the brightness on a colored image. So let's try to do that over a grayscale image. So this is the same image that we analyzed some time ago. I have now already extracted the grayscale green channel image here, and I can always enhance the contrast here so that I can make my no template controls look very black and these look white, because I know that my 10 to the 1s, 10 to the 2s and 10 to the 3s are generally brighter than this, but here it appears that this is also white. So just for the sake of better visualization, you can do some tricks. Now you can again do image adjust brightness and contrast. Now bear in mind that all of this movement of the line that I was doing here, none of it actually changes any of the original numbers. And if you analyze them, even after you adjust the brightness and contrast, as long as you have the original image, you will still get the same numbers. However, as soon as you change, when I save that AVI video, all the changes saved in it, the brightness and contrast saved, has been saved in that image, and you've lost the original content. Therefore, always whenever you do changes, make sure that you don't overwrite the original content. Okay, so that's what I'm trying to say here is that this is where most of my data exists. Okay, my program says this is white, but I can say that my white can be over here, right? See how things are becoming much sort of clearer or brighter here. My signals are appearing very bright. Some of it might be overexposed. What is overexposed? I'm telling ImageJ that this is white, but there are some pixels over here, and those will simply appear white. It's not the best idea to do that generally. But I'll still, for the sake of illustration, keep it here. But what I really want to do is get rid of the white color that is coming from the no template control. So I'll go on the lower end and I'll drag this. Okay, so you'll see progressively that all the lower intensities will begin to appear. Now if you want to make it really extreme, you can go all the way till here. All of the NTCs are more or less gone. All of the others are more or less are sort of visible. This is also kind of eye-opening. This tells you that this entire histogram of pixels is really junk. A lot of this was basically just coming from the background, and these white intensities that are actually representatives of your color are all within this region here. Let's say for argument's sake, actually let me move this back because I'm not really, okay, I like that better. Now I'm going to apply this. Okay, now you see that between 0 to 255, basically it has rescaled this, so it's saying that this is 255 and this is 0. All that histogram here is now gone. Now I can do an interesting thing. This is called as image lookup tables. What you can do in lookup tables, you can take a grayscale image, which is a black and white image, and make it look colored. So if I choose green, wherever there is white will become green, and brighter white will become bright, more green, grayish will become less green, and black will remain black. And this is how my image looks now. This is something you could save, and this just makes if you want to make a point that your presence of target is different than absence of target, this tells your story in a much better way. This is not unethical, because if you do the quantitative analysis, you will still see the same difference between intensities over here and the no template controls. This is just a way to visualize or make images that look better. Now you can say file, save as JPEG, and you can save it as a JPEG, and that you can use in any of your presentations. I think that covers my topics. So this was the last thing I wanted to go over. Let's go over these quickly. I think that you do understand that an image can be represented by just a set of numbers. You now know how to quantitatively analyze color intensities. You know how to quantify distances and areas, and improve image/video appearance for making good presentations or for use in publications. With that, I will conclude this tutorial.